Hello, folks. This is your practice problems video on trigonometry. I've got 6 questions for you here as some extra practice and different ways that these problems might show up, and a couple of word problems for you at the end. So let's go ahead and jump into it. Okay, so for this first one, we're simply writing ratios. Okay, so you don't have to really solve anything here. We're simply looking at picking an angle and then using that angle, its opposite and adjacent sides, and the hypotenuse of this right triangle in order to write the fractions, right, that go with each trig ratio. And then it does say to write each ratio in simplest form, so we're going to end up reducing the fractions, okay? Just to make that part a little bit easier for myself, I'm going to see if I can find a common factor between these 3 side lengths, the 27, 36, and 45. And if I'm looking at these, all 3 of these numbers are multiples of 9. So what I'm going to do, just to try to reduce the numbers at the start, rather than having to do them in each part of the problem, I'm going to divide all of these by 9. Right? And again, the only reason I'm doing this is because the question asked for the ratio in simplest form. So 27 divided by 9 is 3, 36 divided by 9 is 4, and 45 divided by 9 is 5. So this is a 3, 4, 5 triangle, right? This is a multiple of a 3, 4, 5 triangle, okay? All right, so let's go ahead and write these ratios. So I'm going to do x first. So I'm going to say that's the angle that I'm concerned with. So I'm going to label my triangle with opposite, adjacent, and hypotenuse. So opposite here, this is hypotenuse, and then my adjacent side is here. So sine of x would be opposite over hypotenuse, because remember, this is our acronym, SOHCAHTOA. Not the most beautiful that I've ever written that, but there's your acronym, SOHCAHTOA. So sine is opposite over hypotenuse, so that's 4 over 5. Okay, cosine is adjacent over hypotenuse, so that's 3 over 5. And then I'm skipping over here to E because that's tangent of x, which is opposite over adjacent. So 4 over 3. Okay. All right, then I'm going to switch my colors here. Okay, in order to do the other angle. So for y, I'm going to do my labeling here in orange. So if y is the angle I care about, now this side becomes the opposite side. This side here is still the hypotenuse, and then this side here becomes the adjacent side. Okay, remember, opposite and adjacent are completely dependent upon the angle that you're looking at. Right? So sine of y is opposite, 3 over hypotenuse, 5. So 3 over 5. Cosine of y is adjacent over hypotenuse, so 4 over 5. And then tangent is opposite over adjacent, so 3 over 4. Okay, so when you switch the angle, what happens is the sine and the cosine switch fractions, right? So like sine of one angle is the same as cosine of the other, right? Which you can see here. And then what happens with the tangents is the fraction flips, okay? All right, so let's take a look at this second one right here. So this one asks us to evaluate, like this, ask us to evaluate the explanation of someone else. So it says, Elena was asked to write an explanation of how to find tangent of angle P. So in this image, I want to find tangent of angle P. So she said, to find tangent of P, I found the ratio of the length of the opposite side to P and the length of the adjacent side. Since these sides have the same length, she said tangent of P equals 1 foot. Okay, so the question is there anything she should have written differently If so, what? And I give you a hint about units, okay? So let's see if her number is correct. So here I'm going to label, right? Label my triangle. Here's O, H, and A. So tangent of P will equal opposite over adjacent. So that's 5 over 5, which is 1. The only issue with her statement was this addition of the unit right here. Okay, because what happens is if this 5 is 5 feet and this one is also 5 feet, then the units cancel each other out. So when you're dealing with a ratio, you're not actually going to have units in your answer. Okay, it's only if you're looking for one of the side lengths that you end up with a unit, like feet or inches or something like that, in your answer. Okay, so that was the only problem with her statement, was the units. So I need to actually note that because it says, what should she have done differently? So essentially her answer did not need units. Otherwise, her math is correct. All right, so let's take a look at numbers 3 and 4. So 3 and 4 are very similar to the other examples that I've done for you in previous videos. So I'm going to do number 3 here, and then I'm going to have you pause and try number 4 on your own. Okay, so this is a trig problem. We're going to go through and we're going to follow the steps. So step 1 is circle the angle that you care about, right? Don't make it hard on yourself by finding another like missing angle. Just use the one that they gave you, okay? And we're going to label the triangle now. So I'm going to draw my arrow through. So here's opposite. Hypotenuse is the longest side, the one across from the right angle. So that's this one, the 25. And that means X right here is my adjacent side, okay? So if my goal here is to find X, right? That's the goal. So I have to find X. Now, notice I have information on every side, either a variable or a number, okay? But I don't want to use this opposite side right here because it has another variable, right? I'm already dealing with one variable. I can't include 2 in my equation. Otherwise, you won't be able to solve for anything. So I'm going to use the X and the 25. So that means I'm using A and H, which is cosine. Okay, so I'm going to do cosine of, and then the angle is 18, equals, adjacent is X. Whoops, let's erase that. That looks terrible. Okay, so adjacent is X divided by hypotenuse, which is 25. Okay, once you get to this point where you've written your equation, now is the time to pull out your calculator. Okay, so I need to do cosine of 18 in my calculator. And when I do, I got that was 0.951 if you round. Okay, equals X over 25. Then since this is X divided by 25, I need to multiply by 25. Right, in order to cancel this out and get X by itself. So again, I'm doing that in my calculator, and when I did, I got that X is equal to 23.78 if you round. Okay, so 23.78. Right? So now let's go through and solve for y. Now here's the deal. Once you have 2 sides, you don't necessarily have to use trig to find the third, because this is a right triangle, so you could use Pythagorean theorem if you wanted to. But for the sake of this video, since this is mostly on trig, I want to do another problem worked out for you with trig, so that way you can see how it would work if we were using trig. But you could use Pythagorean theorem here if you wanted to. Okay. All right, so let's find y. I'm still dealing with 18 as my angle, okay? But this time, if I want to find y, then I should use O and H. I could use A, like I could use the adjacent side since I know what that number is, but that number has a decimal in it. It's just a little bit easier for me to deal with if I use the lovely whole number that they gave us in the problem. So I'm going to go ahead, since I have O and H here, I'm going to use sine. So I have sine, again, of 18 equals, and it's y over 25. So we're going to follow the exact same process that we did for the last problem. So I'm going to figure out what sine of 18 is by plugging it into my calculator, and I got 0.309. So that equals y over 25. And again, I'm going to multiply by 25 on both sides in order to get y by itself. And when you do, I got that y is equal to 7.73 if you round. So 7.73. All right, you all. So I would love for you to try number 4 on your own. Keep in mind that for this one, since one of the values that you're looking for is the hypotenuse, in some of these problems, the variable is going to be in the denominator of the fraction instead of being in the numerator. So you'll have to do the little switch trick, right? Once you get the decimal value, to switch the variable, which is in the denominator, with the decimal value that you get from your trig function. All right, so give that a try and then check back with me in a sec to see how you did. All right, folks, so go ahead and check your answers against mine. So for number 4, 72 is the angle that I used. If you go ahead and label it, the x is your opposite side, the 8.5 is your adjacent side, and then y is the hypotenuse. So I went ahead and found x first. So if I'm looking for x, I'm going to use O and A. So that's tangent. So tangent of 72 equals x over 8.5. And then I went and followed the exact same process that I did in the other 2 parts of the previous problem. Okay. And I ended up getting that x was 26.16 if you round to 2 decimal places. Okay. Now, for the second part, to figure out what y is, right? Y is the hypotenuse here. So I'm going to go ahead and use the number they gave me, 8.5, which is adjacent, and what I'm looking for, which is hypotenuse. So A and H is cosine. So I'm going to do cosine of 72 equals adjacent, which is 8.5, divided by hypotenuse, which is y. Okay. So this is one of those where it's going to look a little bit different. You can't just multiply the 8.5 over to the other side because that won't cancel it out. Okay, so I plugged cosine of 72 into my calculator and got 0.309. Okay, and then so you end up with 0.309 equals 8.5 over y. Whenever you have an equation like this one, where you have a number equals a fraction, and the variable that you're looking for is in the denominator or the bottom of the fraction. Remember, the shortcut is you can take the value on the other side of the equal sign, which in this case is that decimal, 0.309, and swap it with your variable. So you end up with y equals 8.5 over 0.309. And when you plug that into a calculator, you get that y is 27.51. All right. Okay, so let's take a look at these last 2. And these last 2 are more word problem based. Okay, so here we're trying to build a triangular garden as shown in the picture. They want us to find the perimeter and the area. Okay, so in order to find the perimeter and the area, I need both the base and the height of this triangle right here. So what I'm going to do is I'm going to label this horizontal side here at the bottom B for base, and then this one right here H for height. Okay, so I'm going to need to use my knowledge of trig in order to figure out what the base and the height are. After that, I can figure out what the perimeter and the area are, okay? So I'm going to go through my steps here and label my triangle. So this is O, this is H, and this is A, okay? So if I want to find the height, I need to use opposite and hypotenuse, so that's sine. So I'm going to do sine of 22 equals opposite, which is H, divided by hypotenuse, which is 15. Okay, I'm going to plug sine of 22 into my calculator. And when I do, I get 0.375 if you round, H over 15. And I'm going to multiply the 15 over to the other side. And when I do that, I get that the height is 5.62 if you round, and that's in feet. So 62 feet is my height. Okay. So next I need to look at and figure out what the base is. So for base, again, I think that you could use your Pythagorean theorem once you know what the height is. But again, for the sake of this video, I'm going to use trig so that we get more practice with trig. And honestly, I think that the trig is a little bit faster rather than having to do all the squaring and stuff that goes with the Pythagorean theorem. So this time, since I'm looking for the base, I'm going to use A and H, which is cosine. But the angle has stayed the same. So cosine of 22 equals the base adjacent over the hypotenuse, which is 15. So cosine of 22, I plugged that into my calculator and I got 0.927, if you round, equals the base over 15. And then I'm going to multiply by 15 on both sides. And when I do, I get 13 point, I'm going to round and say that's 91, and that's feet. So that is my base, okay? So once I'm done here, though, I have to check back and see if I've actually answered the question, which I haven't. They want us to find perimeter and area. So as a reminder, perimeter is just the sum of all three sides. So this height was 5.62, and this base was 13.91. So in order to get the perimeter, I'm going to add all three side lengths. 5.62 plus 13.91 plus 15. Right, and when I did that, I got that the perimeter was 34.53, and then I need to use my units, which is feet. Okay. So that's perimeter. And then for area, I gave you a formula, just in case you didn't remember. So to find the area of a triangle, you do base times height, and then cut that number in half. So divide it by 2. So my area is 1/2 base, which is 13.91, times height, which is 5.62. Okay, so what I'm going to do in my calculator is 13.91 times 5.62, and then whatever number I get, I'm going to cut that number in half. So you can say divide by 2, or you can say multiply by 1/2, or multiply times 0.5. So my area here, when I plugged all this into my calculator, I got 39.09 if you round. And now my units on this one is not just feet, but feet squared. Okay, whenever you're finding area, your unit is always feet squared. When it's volume, it's feet cubed, right? Area is 2-dimensional. Perimeter is 1-dimensional, so there's no superscript here. And volume is 3-dimensional, so it would be cubed if it was volume. But for area, it's whatever the unit is squared. All right, so let's take a look at the last one here. So with this one, I'm going to help you draw the picture. Okay, and then after that, I'm going to see if you can set the trig up and actually go through and solve the problem. Okay, so let's take a look at this. This says the longer diagonal of a rhombus measures 20 centimeters. Okay, so they're telling me I'm dealing with a rhombus, so I'm going to go ahead and draw one. Right, so remember, a rhombus is a type of parallelogram where you have all four sides are the same length. So like this side, this side, this side, and this side are all the same length. Okay, and it has a couple of other properties which I listed for you here. But question is talking about diagonals. So let's go ahead and draw the diagonals in. Okay, so there's one diagonal. And then here is the other diagonal, okay? So it says the longer diagonal is 20 centimeters, okay? So what that means is that from here to here, well, that length is 20 centimeters, okay? And then it says the rhombus has an angle that measures 100. So it's one of these bigger angles. See how you have like an acute angle and an obtuse angle? So this whole big angle right here is 100. Okay. So now they want us to find the perimeter of the rhombus. Okay. So that's a fair amount that we have to go through and do. And it may seem like you don't have enough information, but we know some properties of rhombuses that are going to help us out here. The first is that the diagonals are perpendicular. So that means you have 4 right triangles inside here. So that means I can use all of my right triangle things. Okay. The other thing that's going to help us is that the diagonals are cut in half and the angles are cut in half. So if this whole thing is 20, then that means this part right here is half of that, which is 10. So this side from here to here is 10, okay? And then the angle is also bisected. So if this is 100, this angle right here is 50, okay? If we are looking for the perimeter of the rhombus, I need to know what each of these side lengths are. So that's where I'm going to put my variable, okay? So if my picture here is a little confusing, what I'm going to do for you really quickly is I'm going to zoom in on that right triangle that I have at the top. Okay, so we're looking for this right here, okay, because that's one of the sides of my rhombus. I know that this angle in the top left corner is 50, and this side length right here down at the bottom is 10, okay? So now that you have your picture drawn, I'm hoping that this will be a little easier for you to solve. So give this a try on your own and then check back with me to see how you did. All right, everybody, so check back with me here. Let's see how you did. So I used the green triangle to more clearly see which trig function I needed to use. It was a little bit less crowded, so it helped me figure out how to label my triangle and which trig function to choose. So I have my 50-degree angle. I labeled my triangle with opposite, adjacent, and hypotenuse. I looked and saw there was nothing for adjacent, no variable, no number, so I can eliminate that one. Right? It's not going to be helpful to me at all. So I'm going to use O and H. Right? And remember, O and H is SOHCAHTOA. Right? So O and H goes with sine. So, and I know I'm using regular trig, not inverse trig, because I'm looking for a side. I'm not looking for an angle. So my function is sine of 50 equals 10, which is the opposite side, over x, which is the hypotenuse. Sine of 50 is 0.766, and that equals 10 over x. I had my variable in the denominator, so I did my little shortcut swap. So I ended up with x is equal to 13.05 centimeters. Normally in math problems, you would stop right there once you have solved for x, but most of the time in geometry, you have to go back and take a look at the actual question and see, did you answer the question? Okay, and the actual question is to determine the perimeter of the rhombus. So all I have right now is the length of one side of the rhombus. But But one of the properties of rhombuses, one of the main properties of rhombuses, is that all four sides are the same length, just like a square. So my perimeter is four times the side length. So 4 times 13.05. You may have gotten uh, one of these two answers here, depending on when you rounded in the problem. Okay, so if you rounded your x and the x value and did 4 times the exact number 13.05, your answer would be 52.20 centimeters. I did not round my x value in my calculator before multiplying it by 4. So I got a slightly larger value of 52.22 centimeters, but that's just because my x that I got was not rounded. Okay. Um, Most of the time with trig problems, like I've said in other videos, as long as you're pretty close, then you're usually okay, right? There's a little bit of a margin of error depending on when in your process you rounded. My advice would be to not round until the very, 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 very end. Right? Once you think you have your final answer, then round. You're going to get a slightly more accurate answer that way. Okay. Um, so that, ladies and gents, is it for this video. Okay, I hope that this was helpful for you if you were struggling a little bit with the trig problems and especially with the word problems. I hope that this was helpful to you. So I will see you in the next video, everybody. Bye, y'all.